Good day everyone. Today we are presenting our practical lab 3 for the DEE 30172. This experiment focuses on testing electronic components such as capacitors, diodes, and transistors using a multimeter.
The objective of this experiment is to understand how to test different electronics components using a multimeter. We also aim to identify whether the components are working properly and determine the type of transistor.
The equipment used in this experiment include digital multimeter, capacitor, diode, transistor, C9012 and C9013. These two are essential for measure resistance, capacitance, and check component condition.
This part we are doing for resistor, and this is the resistor value results on this table.
For capacitor testing, the multimeter is set to capacitor mode. Then the probe are connected to the capacitor terminal. The reading is observed and recorded. This helps us determine when the capacitor is function properly.
For the transistor, we check the NPN and PNP and tested using a multimeter the forward and reverse bias resistance. So these are the clippings which we check the resistance of the transistor.
For diode testing, the multimeter is set to resistance mode. The probes are connected in both forward bias and reverse bias conditions. In forward bias, the diode shows low resistance, and in reverse bias, it shows high resistance. This confirms that the diode is working correctly.
So this is the question and discussion part. Based on results in table 3 and 4, determine the type of transistor for C9012 and C9013 and explain the answer. So C9012 transistor is a PNP transistor. It flows current and base is negative related to emitter and shows correct forward and reverse bias characteristics. The C9013 transistor is NPN transistor because it flows when base is positive relative to emitter and matches standard NPN behavior, and the emitter at a lower potential compared to base and collector. So as a conclusion, the component readings are to be expected exact. However, in practical situations, reading may slightly differ due to component tolerance and real conditions. So results such as open circuit and short circuit are clear, but in practical, the readings may fluctuate due to instrument limitation and connection issues. So the accuracy of reading depends on the user's skill in handling the multimeter, while theory is basically pure on concepts. Overall, the practical work helps to better understand more than theory because students can observe and measure actual component behavior using a multimeter. Thank you so much for watching.